In today's video, we're going to learn another factoring technique, which is used to factor sums and differences of cubes. So first, let's talk about what a sum or a difference of cubes is. So these are similar to differences of squares. So a sum of cubes looks like anything cubed plus any other thing cubed. Okay, the A and the B could be numbers, they could be variables, they could be a combination of numbers and variables. So for example, a sum of cubes that you might look at would be x cubed plus 8. Okay, we know that x cubed is obviously something cubed, and 8 is 2 cubed. So we could use a sum of cubes technique to factor that. We could also do something like 27 minus 8x cubed. Right, that would be another one. We could factor that, or we could rewrite that as 3 cubed minus 2x all cubed. And that would be another thing we could use to factor a sum of cubes. A difference of cubes is very similar. It's just a cubed minus b cubed. So it could be anything cubed, like x cubed minus another number cubed. So this would we could rewrite as x cubed minus 2 cubed. So that's a difference of squares. Now, whenever we factor a sum or difference of squares, remember we're trying to break down a polynomial into things that are being multiplied together rather than a bunch of things being added up. So if I am factoring a difference of cubes that looks like a cubed plus, sorry, that's a sum of cubes, a cubed plus b cubed, I'm actually going to end up with two sets of parentheses. One is a binomial, so it has 2 terms, and then one's going to be a trinomial, so it has 3 terms. So again, we've got this binomial, and then we have a trinomial. So the binomial is a plus b, and then the trinomial is a squared minus ab plus b squared. So that's how you factor out a sum of cubes. Now let me show you how we factor out a difference of cubes. It's very similar. This is going to be an a minus b as the binomial, and the trinomial is a squared plus ab plus b squared. So you'll notice that these factorizations are pretty much the same except for the 2 sets of signs that I have circled with my highlighter. So the trick here is just remembering what signs go where. So you'll have to remember the A's and the B's, and they'll be exactly the same for the sum and difference of cubes. And I'm going to teach you an acronym to help you remember what the signs are. So if you'll notice that you have a total of 3 signs in your factoring. Now, the first sign is always the same as what you started with. So for example, if you're factoring a sum of cubes, then the first trinomial is going to be, the first binomial is a sum, so you're going to add there. If you're subtracting and you're doing a difference of cubes, then your binomial is also going to be subtraction. Okay. The second sign is, let me switch back to black. The second sign is opposite. Okay, so if your first sign was positive, then your next sign is negative. So you do the opposite sign. Then the last sign is always positive. So no matter what you're factoring, whether it's a difference or sum of cubes, this sign at the end is always going to be a plus sign. So the acronym that you are going to remember, or that you don't have to remember, but it might help you remember what the sign changes are, is SOAP. Your signs are same, opposite, and then always positive. Okay, let's take a look into a few specific examples. I'm going to adjust this so that we can still see our acronyms, so that we don't get confused. Let's start by factoring a difference of cubes. So let's start with x cubed minus 8. Okay, I'm going to rewrite this so that we can clearly see the perfect squares, the perfect cubes. That's the same thing as x cubed minus 2 cubed. So if we think back to our a's and our b's that we were dealing with before, our a is kind of like our x, and our b is kind of like our 2. Okay. So I know this is going to factor into a binomial and then a trinomial. Okay. And the binomial is x minus 2. So I have whatever the cube root is of the first term and then the cube root of the second term. And the sign is the same, like our SOAP acronym says. Then I'm going to have your a squared, so x squared. And now my sign is going to be opposite what I started with, so now my sign is going to be addition. And then it's going to be a times b, so 2x. And then my last sign is always positive, so plus. And then my b squared, so plus 4. Okay, and this is how you factor a difference of cubes. Now we would want to look at this quadratic or this polynomial that has a degree of 2 right here and see if we could factor it any further. Most of the time, if not always, this is going to be prime, which means that we can't factor it any further. So we would just leave the factorization like that. Okay, let's look at another example. Let's look this time at a sum of cubes. Now this one's going to look a little different to start with. So this one looks different because we don't have anything cubed. We have something to the 4th power, and then we just have a regular x. Now, neither of these terms, the 27x to the 4th or the 8x, neither of those are perfect cubes. So initially my thought is, well, we can't use the sum of cubes technique here. We actually can. What we need to do first is use another factoring technique. We need to factor out the greatest common factor of these two terms, which is x. So I'm going to factor an x out, and then I'm left with 27x cubed plus 8. Now that set of parentheses, this factor, that is now a sum of perfect cubes. So let me rewrite this so it looks a little more familiar to us. We're going to have x, and I'm going to employ the brackets so we don't get confused. 27 is 3 cubed, so I can turn that into 3x cubed plus 2 cubed. Okay. And if it helps you to identify what the a and the b are, go ahead and do it. So in this case, our a is 3x and our b is 2. Okay. So I'm going to bring the x down because that's just kind of going to be hanging out up front. It's just another factor that we're going to be using in our factorization. And then my sum of cubes is going to factor into a binomial and a trinomial. The binomial is our a and our b, and it's the same sign as what we started with, so we're adding, right? Then it's going to be our a squared, so 3x squared, which is 9x squared. Don't forget to square the 3 and the x. The opposite sign, so subtraction. And then a times b, so 2 times 3x is 6x. And then my sign is always positive, so addition. And then the last term is b squared, so that would be 4. So this right here would be our factored form of the polynomial. So important things to remember from this example are that you sometimes by employing multiple factoring techniques, you're going to be able to get to factored form. So in this case, we had to use 2 factoring techniques. We had to factor out the greatest common factor of x, and then we had to factor the sum of perfect cubes, and that was able to allow us to factor all the way down to its factored form.